Trig proofs, the basic 8 identities, and this is week 8, task 1. So in this video, we are learning new information. We are talking about trig proofs, basic 8 trig identities. So an identity is an equation that is true for all values in which the variables are defined. So you already know some of these reciprocal identities. For example, cosecant is the same as the inverse of sine, okay? Or 1 over sine, not the inverse, sorry, the reciprocal. So sine and cosecant are reciprocals from each other. Secant is the same thing as the reciprocal of cosine, and cotangent is the reciprocal of tangent. So those are ones that you already know. You already know that sine and cosecant are reciprocals. So normally if we have sine is 3 over 4, then we say cosecant is 4 over 3. We're taking that fraction and we are flipping it, and so that's what these are listed out below as the reciprocal identities. So ratio identities then, tangent is the same thing as sine over cosine, okay? Normally, tangent is y over x. Well, we know sine is y, okay. Sine is, stop. Sine is y over r, cosine is x over r. So if we do y over r over x over r, flip it and multiply, we get that y over x, which is your tangent identity. Okay, so tangent is the same thing as sine divided by cosine. If you were to, like I said, write out sine, write out cosine, divide them. When we divide fractions, we really flip and multiply. Cancel out, you're left with y over x, which gets you back to tangent. So the ratio identities are just showing you the ratios. If you see tangent, it's the same thing as sine over cosine. If you see sine over cosine, it's the same thing as tangent. So then cotangent, remember cotangent is the reciprocal identity of tangent, so we would flip it. Cotangent would be the same thing as cosine over sine. So then the other parts of the basic 8 are the 3 Pythagorean identities. Okay, so remember your Pythagorean theorem is you can take a squared and b squared and it equals c squared. In this case, some of those are 1. Because remember way back when we originally talked about sine, cosine, and tangent and setting those up, we talked about a circle that has a radius of 1. So that's where the 1 is coming into play. When you see 1 in these, they are Pythagorean identities, where if you took sine squared and cosine squared and added them together, it would equal that radius. Okay, because we would make like our little triangles with our x and our y and our radius of 1. So with these identities, if you just believe me, that's perfectly fine. I can go into further depth with them, but because I'm not there with you, I don't want to freak you out. I can't see your faces if you're freaking out right now, so I don't want to go too deep to where I confuse you. And so with these, you basically just need to accept that these identities are what we are telling you. And then with the Pythagorean identities, know that you can move them around. So for example, sorry y'all, I don't have COVID. I don't think. If I do, I don't know how I got it. So if I were to take this Pythagorean identity and move sine squared to the other side, then I also have the identity that cosine squared is 1 minus sine squared. That is another Pythagorean identity that is based off of this original. You could do the same thing with sine. So if I move cosine squared, then sine squared theta would be 1 minus cosine squared theta. So there are going to be times where you're going to see like 1 minus cosine squared theta. Can't do a whole lot with this, but you can turn it into a sine squared, which sometimes helps you with factoring. Now the same thing would apply here with the 1 plus cotangent squared equals cosecant squared theta. So I can, if I start with this, I can move cotangent squared. So 1 could equal cosecant squared theta minus cotangent squared theta. And really, like I said, a lot of this comes into play with like factoring and rewriting. And then if I started here again, because this is, oops, sorry, forgot some things. This is my basic identity. I could also move 1. So cotangent squared theta would be cosecant squared theta minus 1. And again, we're just going to use these identities in like rewriting. We're not going to do anything super crazy. And remember on your assessment, there is, if you haven't seen it yet, there is a basic 8 little piece of paper that you can have. You can rewrite it or you can print it out if you have a printer. If you don't have a printer, no worries. Take a picture of it, write it down on another piece of paper. But that is something that you would want to have, and we're going to sum it all up down at the bottom. So then this last one, as you could probably figure out, I can move tangent. So 1 is secant squared theta minus tangent squared theta, okay? So if you notice here with these two, both of them have a 1 equals. So there are times when you're going to see a 1 and you would want to replace it with cosecant minus cotangent. There's going to be times where you see a 1, you want to replace it with secant minus tangent. Okay, so just know that there are different times for different things. And then as you probably could figure out, we could move 1. So tangent squared theta would be secant squared theta minus 1. Okay, so just to sum these all up, and this is basically the piece of paper that you can use. For your reciprocals, cosecant is 1 over sine theta, secant is 1 over cosine theta, and cotangent is 1 over tangent theta. Remember, you're just writing a fraction 1 over the reciprocal function. For your ratios, tangent is sine divided by cosine, so cotangent is cosine divided by, sine. And then your Pythagorean identities, sine squared theta plus cosine squared theta equals 1. 1 plus cotangent squared theta equals cosecant squared theta. And 1 plus tangent squared theta equals secant squared theta. So again, I can go into further depth with those if you want to shoot me a message and I can really explain where they come from. But all you need to be able to do is to simplify each of these to a single trig function. So single trig function, we're talking sine or cosine or tangent or, like sine squared. Any of those are a single trig function or a number. Okay, so for the first one, sine theta divided by cotangent theta. Remember up here, cotangent is the same thing as cosine over sine. So I'm going to leave that first one alone. And I'm going to replace cotangent with cosine over sine. Now we know when we multiply, if you have something on the top and the bottom, they cancel. And so this can be simplified to cosine theta. And that's all we are doing on these problems. So you don't really have to understand where the trig identities come from as long as you understand to use them. So the next one, sine squared theta over cosine times cosecant theta. So cosecant theta is the same thing as 1 over sine. And then I will leave this as sine squared cosine theta. We have a sine on the top and the bottom, so this would knock down to just be 1 sine on the top. And then we haven't touched cosine. And then we know sine over cosine is the same thing as tangent. So what we're really doing is taking this ugly, oh, I lost my mouse. There we go. Taking this ugly trig function and turning it into one nice, pretty basic single trig function. So number 3, we're going to have to do a little multiplying. So when we multiply this out, this is a difference of squares. So we would have sine squared theta minus 1. Keep in mind, you can write out all of your steps, totally fine. And then with our sine squareds, that's almost like this one. I'm sorry, almost like this one, but it's backwards, right? Because we have cosine squared theta equals 1 minus sine, and then down below we have sine minus 1, okay? So what we can do is factor out a negative 1, so that we'll have negative sine squared theta plus 1, or the 1 minus sine squared theta. And this part we can reduce to be cosine squared theta, and then just bring down that negative in front. And so now I have one trig function. Notice here I still have a trig function and a number, so I need to keep going until I have just a trig function. You can have a number in front, but nothing like added or subtracted to the back. For number 4, we're going to distribute. So we have sine cosecant, minus sine squared x, okay? And then cosecant right here, we know this is the inverse of sine. Okay, so those are basically going to go away. So let me choose a different color. I am left with 1 minus sine squared x. We just talked about up at the top. Where's my mouse? Okay, 1 minus sine squared theta is the same thing as cosine squared theta, or cosine squared x. So I have now also reduced that to be one trig function. And then the last one, we have 1 minus sine x cosine x. And then instead of tangent x, we can put sine x over cosine x, because we're trying to get these all in like terms, basically. The cosines cancel, and we have sine squared x. And then like we just talked about up here, 1 minus sine squared x is cosine squared x. So you're basically just using these identities to simplify the following functions into one trig identity. We aren't taking this a step further right now, but the reason you would want to be able to do this is for factoring. It's a lot easier to factor something with a tangent than it is for like sine squared theta over cosine times cosecant theta, okay? So simplifying these trig functions.